Okay, so today's lesson we will be working on AKS 17, and AKS 17 states, given two figures, use the definition of similarity in terms of similarity transformations to decide if they are similar. Explain using similarity transformations the meaning of similarity for triangles as the equality of all corresponding pairs of angles and the proportionality of all corresponding pairs of sides. Okay, so that's a lot of words. So in a nutshell, what we're going to do today is we are going to determine if two figures are similar. And we are going to use what we learned prior in Unit 1, Transformation Unit, the rigid transformations, which was translation, rotation, and reflection. We are going to use those rigid transformations, plus we're going to add dilations. Dilations is a transformation that is used to make a figure smaller or larger. So the figures we're going to use for our lesson is these two quadrilaterals. So we are going to determine, is quadrilateral ABCD similar to quadrilateral AEFG? So let's remind ourselves, when we did Unit 1 transformations, which were the rigid transformation, those transformations allowed us to move a figure onto another figure, and they were exactly the same. The angles were the same, the size was the same, the area was the same, everything was exactly the same. They were congruent figures. Well, today we are going to look at the figures being similar, therefore they're not going to be congruent but similar, and like our AKS states, what that means is, for similarity, is that the angles are going to be congruent. The corresponding angles are going to be congruent, and then the sides are going to be proportional. So looking at this figure ABCD, I want to determine, is it similar to AEFG? Now some students are going to look at it and go, yes, they look similar, they look like they're similar figures, but we don't just want to assume they're similar. We want to prove and justify our reasoning. So let's talk about something that's similar that makes sense to you before we even talk about these two figures. So imagine you have this sheet of paper, right? And I have a sticky note. Now I'm telling you the sticky note is similar to this sheet of paper. Why? Because if I was to put my sticky note, say, right here, and I was to just line this up like this, right? You should see that the angles on my sticky notes are all going to be 90-degree angles. The angles on my sheet of paper here are all going to be 90-degree angles, and I know the angles are the same. And then when I look at the sides, I can tell my sticky note obviously is smaller than my sheet of paper. But if I know the measurement of my sticky note, I can tell you for sure that this is proportional to that. This side is proportional to that side. This side is proportional to that side. And this side is proportional to that side. Meaning, if I was to measure this sticky note, or this other sticky note, or this other sticky note, they will all be the same measurements. Therefore, they would all be proportional to my larger sheet of paper. So that's what we mean when we say two things are similar, is the sides are going to be proportional while the angles are exactly the same. Okay? So let's go back to our two figures. Quadrilateral ABCD. Now, if you wanted to look at it and go, okay, I know my three transformations that I learned in Unit 1, rotation, translation, and reflection. I'm going to use those here, but I don't want you to guess on which one would work. Which one should I use? Let's go back and use some of the things to help ourselves that we use in Unit 1, like our patty paper. We used patty paper in Unit 1 when we were doing our transformation, so it would be smart to use it again. So if I want to know if this figure is similar to this figure, first I have to do some transformation. So let me go ahead and sketch the smaller figure, A, B, C, D, my quadrilateral. And what we're going to do is we're going to see what transformation can I do so ABCD will look like AEFG, right? Okay, so let's hold that down right here. And what if we wanted to translate? Let's just run through our rigid transformations real quickly and see who would work here. What if I wanted to translate? So I would either be sliding it down and over, or slide it over then down. And if I do that, does it look like ABCD would be the same figure? So let's try it. So I'm going to slide it over and then I'm going to slide it down. No, it's obvious. A translation is not the rigid transformation that would work here. What about rotation? Let's try rotation. What if I was to rotate it? So I need something to hold it down in the middle. So it'll stay as I rotate it. Okay, so I'm going to use my finger. I'm going to use the pen actually and hold it. That's easier. What if I rotate it 90 degrees? Right? Obviously, that's not working. What if I rotated it another 90 degrees? So now I've done 180. Does this figure look like it could be similar to, does this figure look like this figure? So here are my sides. Yeah, that works. That works. So let's use that. Let's go with that. Let's go with the fact that rotation of 180 degrees, right, got me this figure. Well, AB right here, I want to see, is it proportional to AE? And BC, is it proportional to EF? And CD, is it proportional to FG? And AD, is that proportional to AG? So that's what we're trying to figure out right now. So what I want to do is I want to show you with that figure drawn on, right? So here was my original. We rotated it, and now we're here. So I'm just going to put this back just to remind ourselves what we were doing, right? So I rotated it, and here we are, right? So I want to go ahead and label. So this was A, this was B, this was C, and this was D. If you don't mind, I just want to label that so you could see. So now we know our angles right here are the same. This angle is the same. And if I was to take these lines and I was to extend them out, then this D will now be right here at G. C will now be down here at F, and B will be right here at E. I have a better figure because F is missing on that one. So hold on, I have another picture. Let me get it so you can see it clearly. That's better. So now we need to determine if these two figures are similar. We already see that the angles are gonna match up. Great. But we also need to verify that the sides are proportional. So how do we do that? Well, let's see what is the ratio between this side and this side. Okay, so that's what we need to see. What is our ratio? So well, let's count. It's a coordinate grid, so we can just count 1, 2, 3. So this is 3, and then 4, 5, 6. This is 6. What about this side? 1, 2, and 3, 4. So we have 3 to 6, or 3 over 6, which is 1/2. And on this side, 2 to 4, or 2 over 4, which is also 1/2. So right now, things are matching up as far as these sides. Now, these sides are diagonal, so we're not just going to count. I want us to remind ourselves in middle school when we were trying to find the length of the side of a figure, we used Pythagorean theorem if it was a right triangle. So what we're going to do is this side right here, I'm going to make a right triangle out of that. Look at that. And now I can find that side. And I'm going to do the same thing right here. I'm going to make a right triangle out of this. Look. And then I can find that side. So let's remind ourselves Pythagorean theorem says the leg squared plus my other leg squared is equal to my hypotenuse squared. So in this case, one leg is 2, my other leg is 4, so that should be equal to my hypotenuse squared. So we have 4 plus 16, which is equal to c squared. So 20 is equal to c squared. Therefore, c is equal to the square root of 20. So that's the measurement of this side. Well, what's the measurement of that side? Well, here we have 1 squared plus 2 squared, which is 1 plus 4, which is equal to my hypotenuse squared. So now I have 5 equals c squared. Therefore, c is equal to the square root of 5. So, is the square root of 5 proportional to square root of 20? Is that equal to 1/2? That's what we got to determine. So, square root of 5 to the square root of 20. Well, let's simplify square root of 20. What is the square root of 20? Simplify, that would be 2 square root of 5. So what is square root of 5 divided by 2 square root of 5? That is equal to 1/2. So this side is proportional to that side because it equals 1/2. And then our last side is CD to FG. Again, we do the same thing. We could draw right triangles. And we can use Pythagorean theorem. And here we have 1, and here we have 1, 2, 3. So 1 squared plus 3 squared is equal to c squared. 1 plus 9 is equal to c squared. 10 is equal to c squared. Therefore, the square root of 10 is equal to c. And here we have 1, 2, and 1, 2, 3, 4, 5, 6. So 2 squared plus 6 squared. So 4 plus 36 is equal to c squared. 40 is equal to c squared. Square root of 40 is equal to c. So I have the square root of 10 to the square root of 40. Well, square root of 40 simplified is going to be 4 times the square root of 10, which is the same as 2 square root of 10. So what is square root of 10 divided by 2 square root of 10? That would be equal to 1/2. So we have now determined that all the sides are proportional because they all have a scale factor or ratio of 1/2. So 1/2 of this side is equal to this entire side. 1/2 of that is equal to that. And 1/2 of that is equal to that. So these two figures, we can say that quadrilateral ABCD is similar to quadrilateral AEFG because all the angles are congruent and the sides are proportional. Now, you are going to, with your partner, you are going to complete this sheet on a transformation challenge. So what you're going to do is you're going to describe if any of these triangles are similar. And if they are similar, you will describe in detail what transformations make them similar. So you will be working by yourself at first, but then you'll be getting with your shoulder partner and you will be discussing your solutions. Don't forget to use padded paper to help yourself as you are working on